Section 1.5, Voting Methods. In this section, we're actually going to go through a PowerPoint. The PowerPoint presentation is actually 79 slides, but we're not going to go through all 79. We're probably going to go through about the first 50. We are not necessarily responsible for the last 30 or so. But we do have about 50 slides to go through here. And the title of the PowerPoint presentation is Voting Theory, the Mathematics of Voting. I'm going to leave it open like this so that I can possibly go backwards once in a while during the presentation. Have you ever got the feeling that voting sometimes seems unfair? You guys sometimes probably notice after a vote happens, after an election happens, some people are angry. Why is that? Is there math behind that? Is there something we can do about that? What is voting theory? Voting theory is the mathematical treatment of the process by which democratic societies or groups resolve the many and conflicting opinions of the members of the group into a single choice of the group. You may be thinking, why do we need a mathematical theory about something so simple as voting? How difficult could it be to find a simple, fair, and consistent procedure for determining the outcome of an election? Can't be that hard, right? When there's only two candidates or two alternatives, then it actually is as simple as you might think. The winner is simply the candidate with the most votes. Things can get tricky, though, when there are more than two candidates. Let me be clear. We are not in this section talking about voting for the President of the United States. That system has its own name. It's called the Electoral College, and there's definitely a lot of math we could talk about there, but we're not discussing that today. I also want you to know, though, the Electoral College, when we elect a winner that way, I know a lot of people think when we vote for president, there are only two candidates. That is not the case. There's several candidates running for president every time we have an election. I know there are two main candidates, usually from the two big parties, but even running for president is not an example of having only two candidates. I want us to imagine a situation where we have five people running for math club president. Let's say CRC has a math club. And let's assume there are 55 members of the math club that are going to be voting in this upcoming election. And we have five people running for president. We have Amelia, Ben, Charlotte, Declan, and Elliot. They all want to be president. We're going to abbreviate as A, B, C, D, E as we go. Let's talk about what's called a preference schedule. A preference schedule looks like this. This is called a preference schedule. Let's try to understand what this is even saying. Like, what does this mean? So the way we're voting for this math club president, remember, we have five people running: Amelia, Ben, Charlotte, Declan, and Elliot. And the way we're figuring out the winner is we ask all 55 members to vote, but they don't just vote for their favorite candidate. They actually rank all five candidates. So they turn in a ballot that has five names on it, 1 through 5. Like, The first person is my first choice. The next person would be my second choice if I couldn't have my first choice, and so on. So that's called a preference schedule when we look at something like this. So 55 people voted. 18 of them happened to turn in a ballot that looked just like this first column. 18 of them happened to turn in a ballot where they had Amelia first, Declan was their second choice, Elliot was their third choice, then Charlotte, then Ben. Another 12 people, just by chance, happened to turn in a ballot that looked like this. They had Ben as their first choice, then they had Elliot, and so on. And then another 10 people turned in a ballot like this. They had Charlotte at the top, and so on. You can see. So all these numbers at the bottom here should add up to 55 if we have 55 voting members. So this whole thing is called a preference schedule. And I want to talk about who do we think should be the winner? I want you to think about that for a minute. Who do you think should be the winner of this election? Different people have different reasonable arguments that maybe they should be the winner. So who is going to be the winner? Well, it depends on the rules of the math club. It depends on the math club's constitution on how they determine a winner of an election. There's a lot of different ways. There's a lot of methods out there that are used in the real world to find the winner of an election. And so we're going to look at 5 different ways to determine the winner of an election. And these are all ways that are commonly used throughout the world. So we'll also look and see where in the world they are used as we go today. First, a couple of definitions. These are a couple of important definitions that a lot of times people misunderstand. One is called majority. The definition of majority is more than half. More than half. A lot of people misuse that. A lot of people don't understand the definition of majority. They just say majority when it's the one that has the most. But actually, the correct word for that would be plurality. Plurality means just most, but doesn't necessarily have to be more than half. So returning to the preference schedule, a lot of times we just look at the first choice. A lot of times when we vote, we only look at the first choice. Those are pretty typical ways to determine a winner, but that's not the only way to determine a winner. Say we had the election and we only asked people for their top choice. That's one of the ways to do this. That's one of the ways to determine the winner. That's probably the simplest way to determine the winner is to only ask people for their top choice. Who has the most first place votes? You can see Amelia has 18, Ben has 12, Charlotte 10, Declan 9, Elliot 6. You can see that right here in the preference schedule. See these first 18 people have Amelia at the top. These next 12 people have Ben at the top, and so on. Notice Elliot You see Elliot at the top twice, but there's only 6 people who voted 4 + 2. There's only 6 people who voted Elliot at the top. So if we only asked people for their top choice, Amelia would be the clear winner. There's no question about it. If we did not consider their second, third, fourth, and fifth choices, Amelia would win. And that's, to be honest, how a lot of elections are determined, but not all of them. Is it a good idea to have Amelia the winner? I mean, you could certainly make an argument that it is. She doesn't have the majority of first place votes, but she does have the plurality. Remember, there are 55 people running, and majority means more than half. Half of 55 is 27.5. So to have more votes than 27.5 would mean you have 28 first place votes. Someone would need to have 28 first place votes to have the majority. Nobody has the majority. Amelia has the plurality of first place votes with 18. So if we just went with who has the most first place votes, Amelia would win. And that's one of the 5 methods we're talking about today. That's called the plurality method. The plurality method says the candidate with the most first place votes wins. That's the most common voting system probably in the world. It is used in most United States elections. It's also used in Canada, India, United Kingdom, and probably lots of other places around the world. That's the most basic way to determine the winner of an election, is to only ask for first place votes and not to consider anything else. So Amelia would clearly win if we were going with the plurality method. But is that a good idea? I mean, those 18 people would think so, but what about the other 37 people? They would not like that idea at all. They would say, if 37 of us believe that Amelia is the worst candidate, how is it possible she should be the winner? If 37 of us have Amelia ranked last, how is it possible that she could win? That's not fair. That's what those 37 people would say. And 37 is a majority out of 55. It's definitely at least 28. So the majority of people can't stand Amelia, yet she's the winner if we are using the plurality method. So let's talk about some other methods. There's another method we're going to talk about called plurality with elimination. Plurality with elimination takes into account not just the top choice, but it takes into account the whole ranking. And this method is carried out in rounds. After each round of voting, the candidate with the fewest first place votes gets eliminated. And then we have a new round of voting with the remaining candidates, assuming no preferences have changed. When only 2 candidates remain, the candidate with the most first place votes win. Now, when we say we have a new round of voting, we don't actually have to have them vote again because we already know their preferences. We can eliminate somebody and we know who would step up and be the person's next choice. So we don't actually have to make people vote again. We have their choices in front of us. So the plurality with elimination method, this is something used in parts of Australia, India, Ireland, London, Bay Area. Plurality with elimination method is used all over the world. So who would be the winner if we used plurality with elimination method in this case? So let's go back to looking at how many first place votes everybody had. Amelia had 18, Ben had 12, Charlotte 10, Declan 9, Elliot 6. Remember, the plurality with elimination method says whoever has the fewest first place votes gets eliminated. So with that being said, Elliot gets eliminated right here. Elliot is going to be eliminated right now. So if we look at this and we say, well, what would happen if we eliminated Elliot? How would that look if we eliminated Elliot? Imagine this table with all of the E's erased. With all of the E's erased, we would only have 4 candidates. So we wouldn't have 5 lines here. We would only have first, second, third, and fourth choice. So imagine this table with all of the E's erased and everything sort of pushed up into 4 choices instead of 5. If we got rid of Elliot, which we're about to do because Elliot has the least number of first place votes, remember, we are going with the plurality with elimination method right now. We're talking about who would be the winner using plurality with elimination. So if Elliot gets eliminated, what happens? One thing that happens is the 4 people that voted Elliot first are now going to have Ben first, right? These 4 people right here, if Elliot just is gone, then Ben bumps into their top position. So if Elliot gets eliminated, Ben is kind of happy about that because Ben picks up 4 more first place votes right here. Charlotte picks up 2 more if we eliminate Elliot. So again, imagine taking this table, erasing all the E's and pushing everyone up into 4 lines instead of 5. That's what we're doing when we're eliminating Elliot. And this is what it looks like if we do that. I'm going to go back and forth a little bit because I think this is really important that you understand how to make these tables. Here's the original preference schedule. Imagine erasing all the E's, bumping everyone up so that there are only 4 lines instead of 5. So Ben and Charlotte are going to be at the top of those last 2 columns, and it looks just like this. That is what it looks like if we erase Elliot, if we eliminate Elliot. And the way plurality with elimination method goes is just keep doing that. Now get rid of the next person. So look at your new preference schedule and say who has the least number of first place votes right now. I see Amelia with 18. I see Ben with actually 16. I know you see 12 in one of the columns, but then there's another 4 in another column. So Ben actually has 16 first place votes right now. Charlotte actually has 12 because Charlotte has 10 in one column and then 2 on the far right column. Declan has 9 first place votes. I think Declan is the least amount of first place votes, so I think we're about to eliminate Declan. So at the moment, it's Amelia 18, Ben 16, Charlotte 12, Declan 9. Since Declan is the one with the least number of first place votes, he gets eliminated. Charlotte's kind of happy if we eliminate Declan. Look what happens with those 9 people. If we eliminate Declan and push everybody up so there's only 3 lines instead of 4, Charlotte's about to pick up 9 more first place votes if Declan gets kicked out. So that's what we're about to do. We're about to eliminate Declan right now. So here's what it looked like just before that. I want you to imagine this table with all of the D's erased and everything pushed up to 3 lines instead of 4. This is what it would look like. Let me show you again. This is really important. You need to understand how this preference schedule turns into this one. If you take this preference schedule and you erase Declan, basically eliminate Declan, there's only 3 left. So you are pushing it up into 3 choices instead of 4. Charlotte's about to pick up 9 more first place votes when we eliminate Declan. And the new table looks like that. Charlotte got those 9 right there. So now we have to eliminate someone else. Who has the least now at the moment? Amelia has 18. Amelia has had 18 for a while. Those first 18 people have her as their top choice. Ben has 16. Ben has 12 plus the 4. Charlotte has 21 right now. Charlotte has 10 plus 9 plus 2. So Ben is currently the least number of first place votes. Ben is about to get eliminated. What happens when Ben gets eliminated? Charlotte's about to pick up a lot of first place votes. Imagine this table with all of the B's erased and everything pushed up into 2 lines instead of 3. It's going to favor Charlotte quite a bit, right? This is what it's going to look like, in fact, right here. Again, if I take this table and I erase all the B's, because Ben got eliminated, it now looks like that. Amelia is still stuck with 18 first place votes, but Charlotte has 37. 12 plus 10 plus 9 plus 4 plus 2. Charlotte has 37. So now Amelia gets eliminated and Charlotte is the winner. So using plurality with elimination, we get a different winner. It's a different way to determine the winner, but it happens to be a different winner. Amelia can't believe it. Amelia said, wait a second, I thought I won like just a few minutes ago. You guys told me I won. I have the most first place votes. That's not fair. It's not fair. Amelia doesn't think that's fair. What's going on here? Remember, these are methods that are used throughout the world in all different elections, and they're trusted methods. There's nothing wrong with these methods. Let's look at a third one. Third one is called board account method. For this method, each candidate gets 1 point for a last place vote. They get 2 points for a next to last place vote, and so on, all the way up to for the first place vote, say there are 5 candidates, they get 5 points for a first place vote. If there were 10 candidates, they would get 10 points for a first place vote. But it's always 1 point for a last place vote, and then kind of work your way up. So the points you will get for a first place vote is always equal to the number of candidates. And at the end, the candidate with the largest point total is the winner. This method is named after Jean-Charles de Borda. He invented this in 1770 as a fair way to elect members to the French Academy of Sciences. A sort of similar method was actually used by the Romans as early as the year 105. So it started to get developed about 2,000 years ago, but the current form that we use it in is about 250 years old. Board account method is used in a lot of places. Slovenia, Ireland, some Micronesian nations. In the United States, a lot of colleges use it when they're making campus decisions. Harvard, Arizona State, UCLA, University of Michigan, University of Missouri, Wheaton College, Cosumnes River College. It's also used a lot when ranking sports teams. NCAA basketball, NCAA football, giving out the Major League Baseball Most Valuable Player Award, giving out the Heisman Trophy in college football. Board account method is used all over the place. And so some elections, some political elections, use the board account method to determine the winner. So how would that go in our math club election? What if the bylaws of the math club was, hey, we always determine the winner using board account method? There's nothing wrong with that. It's a commonly used method all over the world. So back to our original slide. This is what that original preference schedule looked like. Who would be the winner using the board account method? Well, remember you get 5 points for each first place vote. In this case, you would get 4 points for each second choice vote, 3 points for a third choice vote, 2 points for a fourth choice vote, and 1 point for a last place vote. It's always 1 point for the last place vote. And in this case, it's 5 points for a first place vote because that's how many candidates we have. Here's what the math would look like behind the board account method right here. Kind of go back and forth and make sure we really understand. It looks like Declan wins. Declan has the most points using the board account method. Let's kind of go through Declan's situation and see why he's the winner. So I started over here. It says Declan 1 times 0. Declan got 1.0 times. What are we talking about there? Remember, 1 point is what you get for a last place vote. I don't see Declan on the bottom row at all. Declan doesn't show up on the bottom row. That's why Declan gets 1.0 times. The next thing for Declan says he gets 2 points 10 times. That means 10 people must have had him in that position. That would be the next to last position. Look at that fourth row. You see the D right there for Declan. You see the 10 right there. 10 people had Declan as their fourth choice. For a fourth choice vote in this circumstance, you get 2 points. We're going to work our way from 1 all the way up to 5 at the top. Always 1 at the bottom. Always start with 1 point at the bottom. 10 people voted Declan as their fourth choice. So Declan's about to pick up 2 points 10 times. That's where the 2 times 10 comes from right there for Declan. Focusing still on Declan, moving our way up again to the third from the last row. Well, the third row, starting at the last. The middle row, 18 people have Declan right there. We're looking at Declan right here in the third. There are 12 people that had Declan right there in that row, but there's another 4 right here. And then there's another 2 at the far right. There's 18 total people, 12 plus 4 plus 2. There's 18 total people that had Declan in that third row. And in this case, you get 3 points for a third choice vote. Remember, starting at the bottom, 1 point, 2 points, 3 points, 4 points, 5 points for the top. But we're at 3 points for that middle row, and there's 18 people voted Declan in that middle row. That's where the 3 times 18 comes from right there. What about the second place? Because you get 4 points for second place. How many people had Declan as their second place, their second choice? Well, it again happens to be 18. It's these 18 on the far left column. Those 18 on the far left column had Declan as their second choice. That's the only place that Declan shows up in that second row. So Declan gets 18 points 4 times. 18, 4 times 18, that's where that shows up. And then finally, how many people voted Declan first? Apparently 9 people did. You get 5 points for every first place vote. That's because there's 5 candidates. Remember, the number of candidates determines how much a first place vote is worth. Apparently 9 people had Declan as their first choice. See the column with the 9? See how they had Declan on top? 5 points times 9. So that's what's going on right here. That's where the 5 times 9 comes from. If you go through all the math on Declan, you see it's 191, and that's the most out of anybody. Declan's the winner. I'm not going to go through the math on every single person, but you can go through and do it on your own if you want to. If you want to understand it a little better, you can go back and forth between this, and then I'll put it on here. You can kind of pause and rewind the video a little bit going between here and here and figuring out the math on everybody. Notice Amelia's last place on this one. Amelia, using the first method, we talked about she was first place. Using the plurality method, Amelia was the winner, and yet she's last place on this one. This one takes into account more than just your top choice. But poor Charlotte. Charlotte is she cannot believe what just happened because Charlotte just was the winner. Like a couple minutes ago, she was the winner using what we called plurality with elimination method. Now Declan is the winner using board account. Charlotte is shocked. Let's pause for a minute and recap. So we've looked at 3 different voting methods. And these are three different voting methods that are commonly used all over the world in all these different types of elections. And none of them are necessarily better than the other. They all have their pros and their cons. But we happen to get three different winners so far. Amelia has won, Charlotte has won, Declan has won. Amelia, Charlotte, and Declan all have valid arguments why they should be the winner. Remember, we're going to look at 5, so we have 2 more to go. The next one is called method of pairwise comparisons. For this method, each candidate is matched head-to-head with each of the other candidates. Each candidate gets 1 point for a win. They get half a point for a tie. That doesn't happen very often. But think of it, usually it's 1 point for a win, and then you don't get any points if you lose. And the candidate with the most total wins, or the most total points wins. So we match everyone up head-to-head. This goes back to the year 1299. Philosopher Raymond Lull invented this method for determining the winner of an election. And this is used currently in different parts of the world, including Sweden and British Columbia. So we match everyone up head to head. What does that mean? Here's back to the original preference schedule here. What does that mean to match everyone up head to head? We have 5 people. Imagine it's like a sports tournament, like a basketball tournament. There were 5 teams. And the way you determined the winner was you just had each team play each other. If you just have each team play all the other teams and see who has the best record, that seems like a very reasonable way to determine the winner of that basketball tournament. Well, similarly for this election, let's have Amelia go versus Ben, just one-on-one. Let's have Amelia versus Charlotte, one-on-one. Amelia versus Declan, Amelia versus Elliot. Let's have Ben go versus Charlotte and Ben versus Declan and Ben versus Elliot. Let's have Charlotte versus Declan and Charlotte versus Elliot and Declan versus Elliot. Those are the 10, by the way. When we have 5 people involved, there are 10 possible one-on-one matchups that we need to consider. So let's talk about how would we know who should be the winner of one of those one-on-one matchups. Let's talk about Amelia versus Ben, for example. Who should win if it's just Amelia versus Ben? Who would be the winner? Well, imagine this original preference schedule with everyone erased except for Amelia and Ben. Imagine everyone gone except for Amelia and Ben. Who would be the choice of the people? Imagine this preference schedule with all the C's, D's, and E's erased and everything pushed up into just 2 lines. Just looking at Amelia versus Ben. Well, these 18 people would still prefer Amelia over Ben, the first 18 people, but all the rest of the columns would prefer Ben. They have been ranked higher than Amelia. They don't all necessarily have been ranked first. Only these 12 people in that next column have been ranked first. But these 10 people, if they had to choose between Ben and Amelia, would definitely choose Ben. They have been ranked higher than Amelia. These next 9 people in the next column, if they had to choose between Ben and Amelia, they would choose Ben. I know they have Ben as their 4th choice, but that's still ranked higher than Amelia. So if these 9 people had to choose between Ben and Amelia, they would choose Ben. Same with the 4 over here and then the 2 on the far right. So it's not a matter of how many people have been first or Amelia first. It's who has been higher than Amelia or who has Amelia higher than Ben. That's what it's about. So if we were doing Amelia versus Ben, Amelia is going to lose 37 to 18. The only people who prefer Amelia over Ben are the first 18. All the rest of them, 12 plus 10 plus 9 plus 4 plus 2, that adds up to 37. All the rest of the 37 voting members would prefer Ben over Amelia. In fact, Amelia is going to lose all of her one-on-one matchups. She's not even going to win one game. She's going to lose all four of these matchups, mainly because Amelia's at the very bottom for most people. So Amelia would lose 37 to 18 every single one-on-one matchup. Amelia would lose 37 to 18. So Amelia is definitely going to be last place using this method again. Amelia is going to go 0-4 in this basketball tournament. Yet remember, we called Amelia the winner using the plurality method in the very beginning of this talk. The most commonly used method around the world is actually the plurality method, but is that fair? Because Amelia is coming in last place. Amelia went 0-4 in this basketball tournament. Should we be calling her the winner, the champion? She can't beat anybody one-on-one. Should she be declared the winner of the election? We did earlier using the plurality method. Let's consider Ben versus Charlotte. If we consider Ben versus Charlotte, there are 16 people who would prefer Ben over Charlotte. If it was just between Ben and Charlotte, there are 16 people who have Ben ranked higher than Charlotte. Who are those 16 people? It's these 12 in this column right here, in that second column. See how Ben is ranked higher than Charlotte in that second column for those 12. Also, these those four people have Ben ranked higher than Charlotte. So Ben would have 16 people supporting him if it was just between him and Charlotte. But the other 39 people would actually support Charlotte instead of Ben. The other 39 people, when I say 39, it's these 18 in the beginning. They have Charlotte higher than Ben. These 12, I'm sorry, these 10 in the third column, they have Charlotte higher than Ben. These 9 in the next column have Charlotte higher than Ben. And the 2 in the far right column have Charlotte higher than Ben. So if you add those up, 18 plus 10 plus 9 plus 2, that's 39. Charlotte beats Ben 39 to 16 in that one-on-one matchup. Charlotte beats Ben 39 to 16 in that one-on-one matchup. Make sure you understand how that happened. This is very important that you can be able to look at this and see who has, for example, between Ben and Charlotte. I just randomly have that one chosen. Between Ben and Charlotte, who would win? In other words, if I erased all the A's and the D's and the E's and pushed it up into a 2-row preference schedule, who would be the winner? Well, apparently Charlotte would be the winner 39 to 16. So Charlotte wins that one-on-one matchup. Remember, there are 10 one-on-one matchups we would have to look at. I'm not going to go through all of them. I'm just going to tell you that Amelia doesn't win any. Ben wins 1. Charlotte wins 2. Declan wins 3, but Elliot wins 4. Elliot goes undefeated 4-0 in this basketball tournament. If we have a basketball tournament with 5 teams where every team plays each other once and one of the team goes undefeated, Elliot goes 4-0 in this basketball tournament. Of course, Elliot should be the winner, right? Well, if we're using pairwise comparisons, which focuses on going head to head, then yes, Elliot is the winner. Elliot wasn't the winner using the other methods, though. In fact, Declan can't believe it now. Declan just won recently using the board account method. Declan is taking this tough. Declan is having a hard time with this news of Elliot now being the winner. Told you we're going to look at 5 different voting methods. Let's look and see what the next one is. So the last one, I believe. Remember, these are 5 different voting methods commonly used all over the world and widely accepted to be fine. None of them are perfect, it seems, but they're all widely accepted voting methods. The last one we're going to talk about is called plurality with runoff. When we're doing plurality with runoff, we actually start by having the initial election. And at that point, we narrow down the list just to the top two candidates. In other words, we eliminate everyone except the top two. And then we have a runoff between those top two. This is similar to plurality with elimination, but it's not the same thing. Remember, plurality with elimination, we eliminated one at a time. So there were several rounds with plurality with elimination. Plurality with runoff only has 2 rounds. You start at the beginning, and then you eliminate everybody except the top two, and then you go see who's the winner out of those top two. In this case, we're going to eliminate 3 people at the same time, whereas with plurality with elimination, we only eliminate 1 person at a time. So remember, here's the original preference schedule. Let's look at all the first place votes. Amelia has 18, Ben 12, Charlotte 10, Declan 9, Elliot 6. That's what the original preference schedule looked like. This was the will of the people. Out of the 55 voting members, this is what they said. 18 of them voted the same way. 12 of them happened to vote the same way, and so on. So who's going to get eliminated if we're using plurality with runoff? Well, Charlotte and Declan and Elliot. Remember, in plurality with runoff, only the top 2 get to stay. We eliminate everybody except the top 2. So imagine what this would look like if we got rid of Charlotte and Declan and Elliot, and we only kept Amelia and Ben. That's what plurality with runoff says. Have the initial election, narrow it down to the top 2, have a runoff. Here's the initial election. The top 2, as far as first place votes are concerned, is Amelia and Ben. Imagine what this preference schedule would look like with Amelia and Ben being the only 2 people on it. In other words, erase all the C's and D's and E's and move everybody up so there's only 2 rows. What's that going to look like? It's going to look like this. Let me say that again. We're kicking out Charlotte, Declan, and Elliot because in plurality with runoff, we're only supposed to keep the top 2. We have to get rid of the bottom 3 in this case. So we're getting rid of Charlotte, Declan, and Elliot. Imagine this preference schedule with all of the C's, D's, and E's erased, and everybody's bumped up now, so there's only 2 rows. It would look like this. I think you can clearly see that Ben is the winner now. You can clearly see that Ben wins 37-18 because Amelia always is just stuck with those 18 first place votes. Everyone else, the other 37 people, 12 plus 10 plus 9 plus 4 plus 2, the other 37 people all have Amelia last. But it's not helping her. She's not picking up any more first place votes, but Ben picked up a lot more first place votes. So using plurality with runoff, Ben is the winner. Elliot can't believe it. Remember just a few minutes ago using pairwise comparison, Elliot was the winner. Now we're saying Ben is the winner, and Elliot is saying, what? What just happened? Tears are going down my cheek. It's not fair. Elliot says, I just beat everybody. I went 4-0 in this basketball tournament. How can I not be the winner? Well, it's because we used a different method. These are 5 different commonly used methods throughout the world. We happen to get 5 different winners. That should be troubling to you. That should be stomach churning. Like, what is happening? That's not fair. It's not really fair to anybody. Well, I guess depending on which method you use, but everybody seems to have a good argument that they should be the winner. And in this example, it just happened by chance which voting method we looked at. It just happened by chance which voting method that particular math club might have chosen as their preferred voting method to determine the winner. A lot of people think it probably doesn't matter which voting method you use, it's going to work itself out. Well, we're seeing that's not the case. We looked at 5 different voting methods and we got 5 different winners. And these are all commonly used voting methods throughout the world. Seems like all 5 people have a good argument that they should be the winner of this election. What's going on here? I'm not saying every time, every single example, every single preference schedule we would have looked at, this would have happened. That is not the case. Sometimes there's such a clear person who is above and beyond everybody else that the same person might win with all 5 of these. That is definitely possible. But it should be troubling to us that this is even a possibility, what we just witnessed. It should be troubling to us that it's even a possibility that we could get 5 different winners with only 5 candidates, just depending on which voting method they happen to choose. That doesn't seem fair to anyone. Each of them seems like they would have a valid argument they should be the winner. Shouldn't we be able to come up with one method for determining the winner of an election that everyone agrees on and it's always fair? How hard can that be? Well, it's not only quite difficult, it's actually impossible. This was proven in 1951 by a guy named Kenneth Arrow, and he unveiled this in his book called Social Choice and Individual Values. Kenneth Arrow, who died in 2017, was an American economist, statistician, writer, and political theorist. He won a Nobel Prize in 1972 for what we now call Arrow's impossibility theorem. Kenneth Arrow taught economics and statistics at several colleges throughout his career, including Columbia, University of Chicago. He spent a lot of time at Stanford University. He spent some time at Harvard University and also University of Cambridge. So Arrow's impossibility theorem basically says there is no consistently fair way to choose the winner of an election. Or another way to say that is a voting method that is democratic and always fair is a mathematical impossibility. Now, what exactly do we mean by fair? That's what we're not going to talk about. I mean, although you can kind of, I think even just as we were going through the presentation today, some of you were probably like, well, that's not fair to this person. That's not fair to this person. And after elections, people are always saying, well, that wasn't fair and this isn't fair. And people are always mad. I think you have just an idea what we mean by fair, but there's actually some definitions of fair um, later in this presentation after slide 50 all the way up to slide 79. We're not going to go through that. We are not responsible for those in this class. But in 1951, Kenneth Arrow came up with what we call Arrow's impossibilities theorem. It says, when voters have 3 or more distinct alternatives, no ranked order voting system can convert the ranked preferences of individuals into a community-wide ranking while also meeting a pre-specified set of criteria. And that's what we're not going to talk about right now is what exactly do we mean by the pre-specified set of criteria? That's what we mean by fair. He's basically saying here, when there's more than 2 candidates, no voting system will always be fair. That's what he's saying here. So here's Kenneth Arrow a long time ago and then a little more recent before he passed away. And his book is called Social Choice and Individual Values. It's a very famous book. So we're gonna kind of come towards the end of the video here, talking just to recap Arrow's impossibility theorem. It's never gonna always be fair, and it's mathematically impossible to find a voting method that is always fair. The mathematical impossibility. I like to imagine maybe you watch this PowerPoint presentation and later in the day your mom asks you, hey, what did you learn in math class today? And I like to imagine you saying, well, I think my teacher just said basically life's not fair, deal with it. And that's kind of a good summary, as troubling as that might be, kind of a good summary of what we did learn today. So if you ever see an election happen and you see angry people, you should be like, yeah, that's what happens. There's no way around that. It's mathematically impossible for there not to have the possibility of angry people because they're angry for different reasons, but sometimes those are valid reasons. Sometimes those are valid reasons why people are not happy after an election and they truly think their candidate should have been the winner. But again, it all comes down to what's the method that is being used to determine the winner. And there is no perfect method. It doesn't exist. It's impossible for a perfect method to exist. That's what Kenneth Arrow said. That's what Arrow's impossibility theorem says. Impossible for a perfect method to exist. One that's always fair. So again, as troubling as that might seem, that is going to be the end of our class, the end of our video, the end of our talk today. Thank you for watching.